Hey, I'm Brian from Non-Fungible, and today I'm going to show you guys how to generate any number of unique images using Python. Now, of course, the first step is going to be acquiring the art itself. You can either create this on your own or hire someone on Fiverr. Right here I have about 118 traits. Um, you only need about 10 traits from 4 different categories to produce 10,000 unique images, but they're going to look really similar. So I would highly recommend 150 to 180 traits for 10K images. Since we're sitting at just over 100, I'm just going to generate 5K. I want every image to look pretty unique. Um, so yeah, let's jump into the code. So if you don't already have an IDE, you're going to want to go to Google and look up VS Code. If you're on Mac or Windows, just download the corresponding version. Okay, so I already have it downloaded, so I'm going to pop it open. I'm going to navigate to the same folder that's holding, and again, I forgot to mention this earlier, but all the folders, you want them to be the same name as the category, and you want all the file names to be the same as what you want the trait names to be. Once you have VS Code installed, you're going to want to go into the extensions here and search up Jupyter with a Y and just install the first one that pops up. Should look like this. That'll basically allow us to run interactive Python files in VS Code. Okay, so we're going to create a new file. That should pop up right there. If it doesn't, just create a new file and save as .ipynb, name it whatever. I'm just going to call this one image generation. Okay, so now we're just going to create a bunch of lists with the same name as the categories. Empty list for now. I'm going to fill them up afterwards, so let me skip to when I'm finished with this. Okay, so now we're going to populate these lists with the file names, which are going to be the same as the trait name. So just pop it open for reference. Put each one of them in quotes so it's a string and separate them with commas. Alright, so we got them all populated. Now we're going to create a new list for each one and just call it the same category name and then percents or whatever you want to call it. We're just going to leave these empty for now. Let me skip to when I'm finished. Okay, now we're going to write a function that based on one variable, which is just going to be the number of traits, we're going to generate random values that are close to the mean, so the standard deviation isn't too high. And so we're going to have to import random, which is just a Python library block of code. We're calling the function generate percents. X is going to be the main variable, which is just going to be a number, right? 15 for backgrounds or however many for the rest. Okay, so we're just going to set a random variable name like A is going to equal the average of all the values. And then we're just going to generate an empty list called percents. And we're going to populate percents with, if it's 15 values and 15 numbers all at the same value, which is going to be the mean. And we already know that the addition of all these values is going to equal 1 or 100%, which is what we're looking for. I'm creating another list called subtract amounts, and I'll show you why later. Okay, so we're going to say for I in range X, which is the total number of traits, we're going to append that average value to every single position. So, we'll have the same number of numbers as traits. Okay, so now we're going to use that random module, and we're going to use the uniform method, which takes in two parameters. The first being the minimum value, next being the max value. We're going to go from 0 to whatever percent we're on at the time of the for loop. And the idea here is if it was any bigger than whatever value we're on, then we're getting negative values, which we don't want. So we're just going to append each one of those values to the second list we created, subtract amounts. And it looks like I may have called it something different, so I'm going to fix that. Okay, we're going to create another for loop that subtracts the subtract amounts from each value and then adds it to the next, and it just keeps going all the way through. We're going to stop one less than the total, just because the final value won't have anything to add to. Um, okay, we're gonna grab percents that we generated from the last for loop. Okay, and we're gonna subtract the subtract amounts from the same value. All right, and now we're gonna add that same value to the next one, and that essentially is gonna make sure that this whole list still equals 1 or 100%. All right, finally we're gonna print the percents. I'm also going to print some of the percents just to make sure it's exactly 1. Because if it's like 1.0 whatever or below 0.99 something, it's not going to work in the rest of the code. So if it does produce like anything other than 1, just rerun it with the same input. Um, and it'll only take like 1 or 2 times. I've tested the code. It's not perfect, but it works most of the time. So just rerun it if you don't get 1 exactly as the sum. All right, so the first one I believe is 15. This is like a quick way to find out if you're on a Mac. Cool. See what we get. We're gonna say yeah, go with Python 3. All right. Look at that. We got some percentages. We didn't have to randomly generate them ourselves. We don't have to do the math. I mean, that would take forever to do it manually. And we're verifying that it equals 1, so this is good. So I can just copy and paste this entire list and then just paste it up in the above block. And we're going to do that for all the categories. So, I'll skip to the end so this video isn't too long. And real quick, I just want to show this. I just ran it a couple times and see how the sum is not 1. And then I run it again and immediately, yeah, after 2 tries, it's back to 1. So just make sure the sum is 1. I mean, you don't want the code breaking later on. Yeah, I just wanted to show that real quick. Cool. So now we have our categories, we have our percentages, and we're now ready to just generate the traits. All right. So creating a variable here. You can call it anything you like. We're setting the number to 5,000, which is what I want to do for this collection. All right. We created an empty list called traits, and we opened up the function. Here I'm creating an empty object called trait. And now, so this style of code right here, all it's doing is generating a key value pair. The keys being the category name, which we're hard coding, and the value being the specific trait that's chosen based on the percentages. Now keep in mind, so the code that we wrote earlier is keeping the standard deviation quite low, right? I mean, there's still good deviation, but as far as like the rarities, I mean, it's super random. I mean, some are rare, and I didn't really care which ones are which. So if you want to move those values around, if you want to manually make certain things more rare than others, then yeah, you can do that. Just make sure that the percentages add up to 1. So I'm going to do this all the way through. I'm going to copy the same line down and let me skip to the bottom of this function. All right, so now we're writing an if statement, and as we're looping through, and we're going to write the for loop under this, we're going to make sure that whatever combination we just generated doesn't exist already in this entire list. If it does exist, then we're going to say rerun the function. If it doesn't exist, then okay, return the trait. We're good, right? All right, so here we're writing the for loop. Of course, the parameter is going to be the total number of combinations. Okay, as we're iterating in this for loop, we're just appending the combination to the list. All right, so we just ran the code, and I didn't add a print statement to the end of the block, so let's go ahead. I mean, the good thing is it's stored in memory, right? So we can just pull that variable out, or the list, sorry, and print the list out. So let's see what we got. All right, there you go. You know, every object in the list looks like got all the categories and a random trait. All right, so now we're gonna add token IDs, and this is pretty easy. I mean, we're just creating another loop and starting it at 0. You can start it at 1 if you want. If you want the first token to be number 1 instead of 0, doesn't really matter. But yeah, here I'm just using 0, and I'm saying I want the key to be called token ID. This is obviously fitting into the ERC 721 metadata standard. Okay, we ran that one, and now we're just going to print the list again, see what we got. And now, as you can see, they all have the token ID and starts at whatever number we gave it, and it goes up by 1 every time. All right, now for the fun part. So we're going to import the pillow library in Python. You can see here I accidentally wrote import twice incorrectly, but I fixed that later on. I am importing image ops, which is only necessary if you're scaling the images or doing some sort of transformative thing if they all don't match up. I kept it in there, but I don't use it for this code because, of course, all the images are in the same resolution size. All right, well, to cap off this for loop, we're going to create a variable that is going to link to the specific image in whatever object we're in. So if we're in the first trait, we're going to get whatever background value from the key value pair. We're going to bring in that image, and later on we're going to make a composite of all of them, combine them, and this is going to iterate through for all 5,000. Okay, I'm going to skip to the end. All right, and now we're going to move on to the next step, which is we're going to use the alpha composite module, and we're doing this because the images have transparent properties, or else you would just be able to do the composite module. And we're going to make a composite 1 by 1, in pairs, and I'm going to skip to the end of this. All right, so we're going to name each file simply the token ID. Just want to keep it simple. All right, and here I'm going to save them into a folder. You don't have to do this, but I just want to keep it cleaner on the right. Make sure you actually create this folder in the same directory though. Now we're going to have it print out every time each image generation is successful. Alright, so quickly I noticed that I did the import incorrect, so I fixed that. Okay, and now we rerun it. And yeah, now you just gotta wait. So I'll check in with you guys when it's done. And by the way, if there are some issues with certain traits not being named the same thing as the files, the code will break. So just make sure you monitor that, and make sure the names that are in here kind of. Oh, sorry. Right now I'm just kind of looking at how they're coming out, and they're coming out pretty good, right? But yeah, just make sure that the file names in the folders are the same as the file names that you wrote down in the first block of code. There may be errors there because you might make mistakes. So just pointing that out. If you have errors, that's probably the reason why. All right, and they're done. So now what you want to do is the upload process. So we're going to use Pinata. Pinata is just a pinning service for the IPFS, which is a similar construct to the blockchain. So I mean, honestly, you could store it in AWS. I don't know if OpenSea handles AWS S3 links. I don't know. I don't work there. I haven't tried it. They might only be configured towards Pinata and Arweave. You can look into that. So if you don't already have a Pinata account, go ahead and create one. And so the way IPFS works, let's say I upload something on my computer just locally, and it's free to do. It can be accessed by anyone, but if no one accesses, let's say, number 4,000 or number whatever, and IPFS goes through its routine kind of cleanup, it'll delete that file, right? And so that's where pinning services come in. They're saying, hey, even if no one wants to download my image, keep it up there, please. And you're paying the pinning service for that. But with a free account and with the free tier, it will actually support like launching 1 or 2 NFT projects without having to pay. So yeah, go ahead and create an account, and let me skip to when that's ready. All right, now we log in, and I'm gonna do all 5,000 in one go. If you have 10 grand, you can do 5 and 5, or it really doesn't matter. It's gonna take some time, But as long as the images are uploaded, you're good. They don't have to be in any specific format, really. So I'm going to skip. Again, it took like around 15 minutes, so just keep that in mind. And yeah, that's that. So in the next video, I'm going to show you guys how to generate the metadata, and it's very easy to do. And really all we're doing is those same traits, so don't delete or close the file that you generated with. We're going to use that same one, the same traits, and we're just going to append the IPFS links to the end of them. So yeah, just check the channel. I should upload that video pretty soon after this first one. See you guys.